The Pythagorean Theorem and its converse. The Pythagorean Theorem is an equation that we use that relates the side lengths of a right triangle. So when you have a right triangle, the two sides that make the right angle, called the legs, are represented with the variables a and b. It doesn't matter which one is which as long as a and b represent the legs of the right triangle. Now the side that's opposite from the right angle, the hypotenuse, is always represented with the variable c. They relate to each other in this equation, a squared plus b squared equals c squared. Now let's go ahead and find the length of the missing side. When we're solving for the hypotenuse, remember, we just want to label the legs. One of them is going to be our a and one will be our b. So we have a squared plus b squared equals c squared. So our a is 5, our b is 12, and our c is x. So now we can solve this equation for x. 5 squared is 25, 12 squared is 144, is equal to x squared. 25 plus 144 gives us 169, equal to x squared. Now from here, we can take the square root of both sides so that our x is isolated. The square root of 169 is 13. So this is our final answer. The missing side length, the hypotenuse, is 13. Let's try this next example. So we're going to go in the same fashion. The two legs, one of them is going to be a, one is going to be b, and then our hypotenuse is c. So we start off with our Pythagorean theorem, a squared plus b squared equals c squared, and then we substitute in our values for a, b, and c. We have 2 squared plus 1 squared equals x squared. 2 squared is 4, 1 squared is 1, equals x squared. 4 plus 1 is 5, equal to x squared. Now this time when we take the square root of both sides so that we can isolate x, if you put square root of 5 into the calculator, you're going to get a decimal answer because 5 is not a perfect square. So we actually want to practice working with radicals, and we're going to leave our answers exact. So your final answer is square root of 5. Now when we're solving for the leg, we're going to go through the same process. It's just our numbers and variables are going to be in a different place. Remember, the right angle, the two sides that make those are going to be our a and b, and our hypotenuse, opposite from the right angle, is our c. So when we have our Pythagorean theorem and we substitute in our values, this time we have 8 squared plus x squared equals 10 squared. So let's go ahead and solve for x. 8 squared is 64. We can't simplify the x squared yet, so we'll leave that. 10 squared is 100. Now in order to get this x by itself, first we're going to have to get rid of the 64. So we need to subtract 64 from both sides. And then we're left with x squared on this side is equal to 36. Now that our x term is alone on this side, we can take the square root to cancel those out and isolate the variable, and the square root of 36 is 6. Now let's go ahead and try this next example. Again, find the right angle, and those two sides that make that right angle are going to be your a and b, and then your hypotenuse is c. So we start off with a squared plus b squared equals c squared, and we want to substitute in our values. So we have x squared plus 7 squared equals 9 squared. We can't simplify the x squared. 7 squared is 49, and 9 squared is 81. So we want to subtract the 49 from both sides so that we can isolate that x squared term. So we have x squared is equal to 32. Now when we take the square root of both sides, we run into that problem again where square root of 32 is going to be a decimal, and we don't want decimal answers. So this time we're actually going to simplify this radical. So let's go ahead and break this down into the multiples of 32. So 32 is equal to 2 times 16, and we'll keep breaking this down into multiples. 2 is prime, so it just comes down. 16 is equal to 2 times 8. The 2 comes down, this 2 comes down. 8 is equal to 2 times 4. 2 comes down, 2 comes down, 2 comes down, and then 4 is equal to 2 times 2. So now that 32 is broken down into its multiples of primes, we can group them in pairs of 2 so that we can take numbers out of underneath the radical. So these 2's pair up and one will get out. These 2's pair up, another will get out, and this 2 has to stay underneath the radical. So our last step is to simplify any numbers that are outside of the radical and any that are inside. So our final answer is x equals 4 times the square root of 2. Pythagorean triples are special lengths of right triangles. So when you have right triangles where all 3 side lengths happen to be whole numbers, that's called a Pythagorean triple. You don't have to memorize these, but knowing these can help your calculations go a bit faster. Next, we want to talk about the converse of the Pythagorean theorem. And in the converse, you're going to be given 3 side lengths of a triangle, and you need to determine whether it's an acute triangle, a right triangle, or an obtuse triangle. We've been talking about the Pythagorean theorem and right triangles. So if you take the side lengths C, B, and A, and if C squared equals A squared plus B squared, then that's going to be a right triangle. If C squared is smaller than A squared plus B squared, then you have an acute triangle. And if C squared is larger than A squared plus B squared, then you have an obtuse triangle. So the only thing you have to do is decide which number is going to be C. So remember, in a right triangle, C is always the longest side because it's the side that's opposite from the right angle. So when you're given 3 side lengths, make sure that C is always the longest side length that you're given. Otherwise, your calculations will lead you to an incorrect conclusion. So here, we're asked to decide whether the numbers can represent the side lengths of a triangle, and then we need to classify the triangle as right, acute, or obtuse. So the first part, this is actually from our previous unit, whether the sides can make a triangle or not. Remember, we take the 2 shortest sides and we're going to add them, 21 plus 28, and that gives us 49. And you want to make sure that that is bigger than the longest side length. 49 is bigger than 35, so it does make a triangle. Now we want to classify the triangle. So remember, the biggest side is going to be C, and it doesn't matter which one of the 2 smaller ones is A or B. And we want to use the Pythagorean theorem converse, C squared, and we're going to put a box here, A squared plus B squared. So let's go ahead and substitute in our values. Our C is going to be 35, A can be 21, and B can be 28. So now let's go ahead and square our numbers. 35 squared is 1225, box. 21 is 441, and then 28 squared is 784. Then lastly, 1225 on the left side, box, and then when you add 441 and 784, you get 1225. So the reason why we put a box there is because we don't know what symbol we're going to put in here. Less than, greater than, or equal to. So when we look at this, the 2 sides actually end up being equal. So since they're equal, we have a right triangle. So let's look at example 2. Remember, first we need to decide whether it actually makes a triangle. So 10 plus 11 is equal to 21, which is bigger than 14. So this does make a triangle. So 14 is going to be our C in our Pythagorean theorem converse. C squared, box, A squared plus B squared. So we put 14 squared, box 10 squared plus 11 squared. So 14 squared is 196, 10 squared is 100, 11 squared is 121. So 196 box 100 plus 121 is 221. So when we compare these two numbers, remember you always want to look at c squared. So c squared is 196. That is smaller than 221. So since c squared is smaller, this is going to be an acute triangle. Let's go ahead and take a look at example 3. So first we need to check and make sure this makes a triangle. So the two smallest sides, 10 plus 2 is equal to 12. 12 is equal to 12, the biggest side. And remember, it has to be greater than the larger side, so this does not make a triangle. Since these three side lengths do not make a triangle, we can't classify it as a triangle, so we're finished. So in example 4, we have decimals and radicals, and that's okay. We just have to make sure that we calculate this carefully. First, when we're trying to decide whether the side lengths can make a triangle, we actually need to know the approximate value of square root of 5. So square root of 5, if you put that in your calculator, it's approximately 2.2. So we're just going to work with that because the two smallest sides would be square root of 5 and 5. So 2.2 plus 5 is equal to 7.2, and that is bigger than the third side, 5.5. So it makes a triangle. So that means 5.5 is our C in our Pythagorean theorem converse. And now we can go ahead and substitute in our values. So our C is going to be 5.5 squared. Our A, we can make the square root of 5 squared. And then our B is 5 squared. 5.5 squared, this is 30.25. The square root of 5 squared, remember those two cancel each other out, so that's just 5. And 5 squared is 25. So we have 30.25 box, 5 plus 25 is 30. And then when we compare these lengths, remember, again, it's based off of c squared, and this time c squared is larger than a squared plus b squared. So when c squared is bigger, you want to think bigger, and that's an obtuse triangle. So that's how we use the Pythagorean theorem converse to classify triangles. That's it for these set of notes. I'll see you in class for more practice.